We're going to finish up lesson 6.5, and I did go in and change these 4 questions. So take a minute and change these on your paper. All right. With trinomials, we're going to use the same steps and do the same things like we did in Unit 5. So if you remember back to there, if there was a number in front of the x squared, that's where we pulled in the box method. So we may be doing that some. So always, always, always look for a GCF. That'll make your question a little bit easier if there is a GCF. So looking at question 21, I've got 2x cubed plus 38x squared plus 68x. Is there a GCF? Yes. What is the GCF? 2x. When we factor out a 2x, we're dividing each term by 2x. So this leaves me with x squared plus 19x plus 34. And then what's left in the parentheses, that's what I factor. Now, there is no number in front of the x squared, so it becomes a lot easier. We want 2 numbers that multiply to be 34 and add to be 19. What are those 2 numbers? 17 and 2. And if you'll remember, we take those numbers and put those in parentheses with the x. So I've got my GCF, which is 2x, and then x plus 17, x plus 2. Number 22, is there a GCF? No, there's not. And there's a number in front of the x squared, which means this is the one where we're going to have to use the box method. Five x squared goes in the top left. What do I put in the bottom right? 6. Now we want 2 numbers that multiply to be what? 30. Remember, 5 times 6 gives us 30. And those 2 numbers add to be what? Negative 11. Yep, negative 6 and negative 5 are my 2 numbers. So those numbers go in here along with an x. Negative 6 and negative 5x. And then what do I do? I come up with a GCF. Remember, I write the GCF out of these boxes. Yeah. So the GCF of this row, I'm going to write here. So what is the GCF? X. Just x. What is the GCF of this row? Negative 1. And it does have to be negative because the first box is negative. What's the GCF of this column? 5x. And this column? Negative 6. It has to be negative because the first box is negative. And those are my factors. x minus 1, 5x minus 6. Number 23. What is different about that question?
There's no number in front of the x.
True. What's different about it than this on number 21? Because on 21, after we did GCF on 21, there was no number in front of the x squared. So what else is different? You don't notice anything different. Yes, the exponents are different. This one is to the 4th power and then to the 2nd power. If you have a question that's x to the 4th and then x squared, then we actually do it the same way, but what we put back in our factors is x squared instead of x. If it was x to the 6th and x cubed, you would put x cubed instead of x. All right, so when we're solving these, we're looking for two numbers that multiply to be 10 and add to be 7, which are what? 5 and 2. So our factors are going to be x squared plus 5, x squared plus 2. And if you want to check that, if you were to go back and multiply, FOIL this out, x squared times x squared is x to the 4th. That would be plus 2x squared plus 5x squared plus 10, which is x to the 4th plus 7x squared plus 10. So you'll see some of those. A lot of the questions that are like this, whenever you get your factors, one of your factors will be a difference of squares. So if this had said x squared minus 9, that would have been a difference of squares. So we will start doing some examples where you factor it one way and you can still factor it again. And you'll have to factor as many times as you can. Number 24, is there a GCF? Is that all? 2x. 2x is the whole GCF. That leaves me with x to the 4th minus 14x squared plus 48. So we need two numbers. There's no number in the very front. Now, if there was a number left in front of this x to the 4th, we would have to use the box method. And you would just use x to the 4th and x squared. There. But there's no number. So multiply to be 48, add to be negative 14. What are those two numbers? You're on the right track. Negative 6 and negative 8. Two negatives multiplied make a positive, but when I add them, they're still negative. X squared minus 6, x squared minus 8. Now, the reason that these are not difference of squares is because 6 and 8 are not perfect squares. The only way you can do difference of squares is if you have two perfect squares. Go to the back and do grouping. Grouping is what we use when we have 4 terms. So difference of squares, sum and difference of cubes is 2 terms. The trinomials that we just did is 3 terms. And we do grouping when there are 4 terms. So to group, there's a few steps we follow. Group the first 2 terms together and the last 2 terms together. So x cubed plus x squared negative 4x minus 4. And then we're going to factor out the GCF of each set. So what is the GCF of x cubed and x squared? X squared. And when I factor out an x squared, what am I left with? Plus 1. What if I factor out the GCF of this side? It needs to be the negative 4. If your first term is negative, it's negative. So then if I divide both of those by negative 4, what do I have? X plus 1. If you do grouping correctly, what you have in parentheses will be identical. Not almost the same, not 1 plus, 1 minus, they will be identical. So then what you have left over, what you have on the outsides, that becomes one of your factors. What you have on the inside becomes your other factor. Could I factor down one of these again? Which one? The first one, this is a difference of squares. Both of those are perfect squares. Yes, we should factor that down, but guess what? I don't have room. I didn't leave room for that, so we'll just stop there. But I should do difference of squares. Take the square root of both of those, and it would be x plus 2, x minus 2. So let's do some examples. And now on these examples, we will factor them completely if there is some more factoring that can be done. So we have x cubed minus x squared and 9x minus 9. What is the GCF of this one? X squared. And we get what? X minus 1. And what's the GCF over here? And we're left with what? X minus 1. So then we take our outsides, x squared plus 9 and x minus 1. Can either of those be factored again? You could. But what's the problem? It's a plus. There's only a difference of squares. There is no sum of squares. So there actually is no other way to factor this down. So this one is complete. Difference of squares only works if there's a subtraction. So if that was x squared minus 9, yes, it would work. But it's x squared plus 9. Okay. Number 26. We have x cubed plus 5x squared and negative x minus 5. What's the GCF of the first one? X squared. Leaving you with what? X plus 5. What is the GCF of the second one? Leaving you with x plus 5. So we have x squared minus 1 and x plus 5. Can either of those be factored again?
Yes. Yeah.
X squared is a perfect square. 1 is a perfect square. And it's subtraction. So it's difference of squares. So difference of squares, a is the square root of x squared, which is what? B is the square root of 1, which is 1. So that first set of parentheses factors into x plus 1, x minus 1. And then we also have the x plus 5. You just have to, every time you just have to ask yourself, can it be done again? Can it be done again? So you have to be able to recognize those are perfect squares. Any variable with an even exponent is a perfect square. Any variable with, if the exponent is divisible by 3, it's a perfect cube. So you always have to be watching out for those things. Number 27. And really, from here on out, a lot of your questions you can factor like twice. It's not always a grouping question. Sometimes you can do difference of squares and then do difference of squares again. Or sometimes you can do difference of cubes and then difference of squares. So pretty much from here on out, you've always got to be watching out for those. First one, what is the GCF? X squared. Leaving you with 4x minus 5. And what's the GCF of the other one? Negative 4. Leaving you with 4x minus 5. When you take negative 16 divided by negative 4, it's 4. And 20 divided by negative 4 is negative 5. I had to make this a negative because the first term was negative. And if I didn't make it a negative, what I had in parentheses would not have matched. So then we have x squared minus 4 and 4x minus 5. Can I factor either of these again? The first one, it's a difference of squares. Do y'all hear the music? Okay, I thought I was going crazy. All right, a is the square root of x squared, which is x. B is the square root of 4, which is 2. And so that factors into what? X plus 2, x minus 2, and 4x minus 5. Don't forget to bring that one down too. Questions? Try number 28. All right, this one factored out a 2x to the fourth, leaving you with x minus 9, and a 7, leaving you with x minus 9. Remember, what you have in parentheses have to match. If you don't get matching things there, then you got it wrong. And 2x to the fourth plus 7, those are not perfect squares. X to the fourth is, but that's it. And x minus 9, x is not a perfect square. It would have to be like x squared minus 9. So you're done there.